Hello, this is Amrit Regmi.
I'm Louis Johnson.
This is our final project from the group 4. We divide this project into three different categories: design and observation throughout the code, and the video presentations. This is the picture how we design our robot.
Right. Originally, we had our brick lying on its back. Basically, we changed our design so that the brick now is mounted on its side. It's mounted more securely over the back wheels, and it gives better access to battery compartment for quick, easy battery changes. One problem that did come from this was a small problem, is that now we have to lean over to read the brick's console display, but we can also access that display by way of our computer when we are using Bluetooth.
Also, we have changed the color sensor from the left side to the underneath the claws.
Right, and we moved the ultrasonic sound sensor from its previous position, which was at first up high, then down low, and now it's in the center forward, pointing downward. That makes it easier for us to spot a change in objects. When we come upon the ball using this, we get a closer readback distance than with at any other time.
Even though we place the force sensor on the robot, we only use the color and ultrasonic sensors.
Right, we do have the gyro mounted, but we didn't make use of it. Our previous plans were to make use of it, but we didn't incorporate those plans.
So this is our maze.
Yep, this maze matches the example maze from the project requirements listing.
So it starts at the E1 right here, and it ends at the blue tape,
which is the E2 position. The tape does not show walls. We don't show walls on this on this maze representation. Only waypoints, the waypoint path.
Exactly. We are not following the tape. Instead of following the tape, which uses the waypoint to go to certain coordinates.
Yep, we chose to use the Move Pilot chassis. We had previously used a differential pilot, and it worked okay for us, although it was not recommended. But we changed to the chassis and chassis and move point pilot. And it works good for us, except for one big problem, is that it's not compatible with with use of the medium motor, which drives the grabber. And for that reason, we were not able to use the grabber
together with the.
We did do a little substitution video for demonstrating that we can capture the ball and retrieve it. It's just a supplemental snippet of video.
So finally, this is our final robot design, which we think is the best position for the wheel movement and high precision, to get the high precision.
We got better precision movement on our turns by counter-rotating the wheels. We would rotate one wheel forward and the other wheel in reverse, and that gave us a center of movement in the middle of the two wheels. It gave us a more predictable center of movement. We use a three-wheel design, which the front wheel was caster, the back two wheels were the usual EV3 wheels.
Okay. So the pros and cons of our project is that we get for the pros we get the accurate precision to follow the line using waypoint. We got a good traction, easy battery replaceable. The major cons we got here is that the grabber function is not working properly, and we made a new discovery here that medium motor is not compatible with the move pilot, which means the grabber function we have used for the assignment is not compatible with the move pilot.
Now, looking at the code, we did, excuse me, we did decide to go with an array to represent all of our waypoints. And originally, we were going to save more information, capture more information about every waypoint. We were previously going to capture information about which waypoints were connected to the current waypoint and the previous waypoint that was visited. But as it turns out, we only ended up using the XY coordinates. We were using the Cartesian coordinate system, and we only ended up using our array to store X and Y coordinate points for each waypoint, and the index number for each waypoint.
So this is all the code part we have done in this project.
Yeah,
So
we did end up calling out each waypoint individually and moving individually from one waypoint to the next.
So in this video, we are generally trying to say that we are able to capture the ball when we run the grabber function separately, but when we integrate that medium motor with grabber function, we are not able to get the right solution. So this is our final video presentation.
We saw it there from the E1, and we're going to traverse the entire maze. This would be the equivalent of searching every point on the maze. And if we found the target at any point in the maze, that would be when we would actually capture it. For our purposes, since we knew that we were not able to close the grabber using our current software, we just demonstrated that we would.
But we can
the target, and we just touched it and moved it to show that we did recognize that it was there.
The only thing we couldn't do here is to grab the ball, which we already mentioned it before.
We're following the depth first method of traversing our path, which means that we take the left path first until we get to the farthest most location. Then we go back and we retrace or go back and track the previous connecting paths, which would be the right path. In this case, we only had one additional path to cover, which is the one that you see being covered now. So in the binary tree, this would have been the last remaining leg to be covered.
We can see that there are very less error on the turning.
The 180-degree turns actually worked out pretty good for us too overall. The way we found how much of a turn we should make at each position was experimentally. We used our robot to go through several paths, and we measured about how much air we had at the end of several paths, and we just kind of divided that by how many turns that we made, and what we found was for making a 90-degree turn that it actually worked out better if we just commanded to make an 88-degree turn. And that works out pretty good for us. It gives us almost 90 degrees over the course of our maze.
So the robot stopped at the exit point.
I think this concludes our video.
Thank you for watching.
Good day.